Hello friends, myself Rajendra Mahajan presenting my video on inverse Laplace transform by convolution method. First example, find inverse of 6 upon s multiplied by s plus 3 by convolution method. Whenever we require to find convolution, inverse by convolution, we have to obtain inverse of first term, that is 1 by s. Standard result, it is 1. Inverse Laplace of second, 1 upon s plus 3 is e raised to minus 3t. Then we have to consider any one of them as f of t and second one as g of t. But as a rule, consider that term as g of t with minimum terms of t. Therefore, here the first one is 1 with no term of t, and therefore we call it as g of t, and the second one as f of t. And therefore, inverse Laplace of 6 divided by s multiplied by s plus 3 by convolution, it is integration from 0 to t f of u multiplied by g of t minus u, and then its integration with respect to u is equal to 6 we can take outside, it is integral from 0 to t f of u replace t by u in this term f of t, and therefore it becomes e raised to minus 3u, and in g of t replace t by t minus u. Here no term of t, therefore it remains 1 only, no change in it, and then integrate that term with respect to u. Integration of e raised to minus 3u is e raised to minus 3u divided by minus 3, and limit from 0 to t. Therefore, taking 3 outside, we get 6 by 3. Cancelling minus sign by changing the limit, 0 become upper and t become lower. Therefore, e raised to 0, it is 1 minus e raised to minus 3t as the inverse of that function by a convolution theorem. Find inverse Laplace of, the terms are 1 upon s square multiplied by s minus 1, again by convolution theorem. And to apply that convolution, once again we find the inverse of individual term. Inverse of first term 1 by s square, standard result, its inverse is t. Inverse Laplace of 1 upon s minus 1, again standard result of inverse Laplace, it is e raised to t, e raised to at, a is 1, therefore we call one as f of t and second one as g of t. Therefore, we call e raised to t as f of t and second one as g of t. Or we can interchange the values, answer remains the same. No change in the answer. And therefore, by convolution theorem or method, inverse Laplace of 1 by s square multiplied by s minus 1 is integral from 0 to t, formula is f of u multiplied by g of t minus u, and then its integration with respect to u. It is integral from 0 to t. In this f of t, replace t by u, it becomes e raised to u. And in g of t, replace t by t minus u, it becomes t minus u, and then its integration with respect to u. Here it is a product of two terms of u, therefore integrate it by generalized part. For this t minus u, we consider as first function as it is algebraic, and second one is exponential, therefore we consider that as second term, and therefore integrating it by generalized part, first term, integration of second, integration of e raised to u is e raised to u, then minus derivative of this t minus u with respect to u is minus 1. Next integration of e raised to u is e raised to u. Next one, derivative of 1 is 0, therefore we stop here as it becomes 0, and then limits from 0 to t. Substituting the upper limit as t for u, therefore t minus t we get 0, minus minus plus e raised to t, these two terms for upper limit, minus lower limit, u as 0, therefore it is t e raised to 0 and minus minus plus e raised to 0, and therefore we get the value final e raised to t, e raised to 0 is 1, therefore minus t, and e raised to 0 1 multiplying by minus sign we get minus 1 as f of t, or the inverse by convolution method. Third example, find inverse of 1 by s multiplied by s square plus 4 by convolution. To apply that convolution method to find inverse, we once again obtain individual inverse. The first one is 1 by s, its inverse is 1. Inverse Laplace of second term 1 upon s square plus 4, 4 means 2 square. It is 1 by a, 1 by 2, sine of at, sine of 2t. Minimum terms of t, here 0 term of t, therefore that term we call as g of t, and the second one as f of t say. Then by convolution theorem, inverse Laplace of 1 by s multiplied by s square plus 4, as per that theorem, its value is obtained by integration from 0 to t of f of u multiplied by g of t minus u, and then its integration with respect to u. Integration from 0 to t, f of u, replace t by u in this term, therefore we get 1 by 2 sine of 2t, sine of 2u, and in this g of t, replace t by t minus u, we get that term as 1 only, and then integrate this product by with respect to u. 1 by 2 constant we take outside, integration of sine is minus cos of 2u and divided by 2, limit from 0 to t. 1 by 4, minus sign we change by changing the limit, 0 become upper, t become lower, therefore cos of 0 minus cos of 2t Therefore, answer is 1 by 4 times cos 0 is 1 minus cos of 2t as f of t as a required answer. Find inverse of s divided by s square plus pi square and bracket square by convolution. Therefore, first step we rewrite that term s upon s square plus pi square and whole square as inverse Laplace of s divided by, we split that square as s square plus pi square and again 1 upon s square plus pi square. If we take a product, we get this s square plus pi square and its square. Then we find individual inverse Laplace of s divided by s square plus pi square. Standard result, it is cos of at cos of pi times t, and inverse Laplace of 1 upon s square plus pi square is 1 by a 1 by pi sine of at sine of pi times t. One is f of t, second one is g of t. Therefore, this 1 by pi sine pi t we call as f of t and second one is g of t. We can interchange these two, but final result will remain the same. And therefore, by convolution method, inverse Laplace of that product s upon s square plus pi square into 1 upon s square plus pi square as integration from 0 to t f of u multiplied by g of t minus u. Then replace t by u, we get integration from 0 to t 1 by pi sine of pi times u, and in g of t replace it by t minus u. We get cos of pi times t minus u du. Here it is a product of sine cos term. To perform its integration, we have to multiply by 2 and divide by 2 so that it becomes 1 by 2 pi integration from 0 to t 2 times sine of pi u multiplied by cos of pi t minus pi times u, and then its integration with respect to u. To perform this integration, we know this result. 2 sin a cos b. This product we can convert to sum by that defactorization result. 2 sin a cos b is sin a plus b plus sin a minus b, and therefore inverse of left hand side is f of t. It is 1 by 2 pi integration from 0 to t 2 sin a cos b is sin a plus b sin of a plus b. A is pi u and b is pi t minus pi u. Therefore, pi u plus pi t minus pi u and plus sin a minus b sin of pi u minus pi t, and minus minus it becomes plus pi u, and then its integration. Simplifying it further, 1 by 2 pi integration from 0 to t sin of pi u get cancelled. We have only sin of pi t plus sin of pi u plus pi u. We get 2 times pi u minus pi t, and then its integration with respect to u. First term we have to integrate with respect to u, which is constant term with respect to u. Therefore, we take outside sin of pi t, and integration of du is u. Integration of sin is minus cos of 2 pi u minus pi t whole divided by 2 pi, and then limit from 0 to t. 1 by 2 pi sin pi t, substitute value of u, upper limit as t, lower limit as 0, minus 1 by 2 pi 2 pi t minus pi t, it becomes cos of pi t minus u is 0, and cos minus theta is cos theta. Therefore, it becomes cos of pi t. And therefore, this cos pi t minus cos pi t get cancelled. Final answer is 1 by 2 pi t sin of pi t as a required inverse Laplace transform. For in this video, I have discussed 4 examples of inverse Laplace transform by convolution method. Therefore, please like my video, share it, as well as subscribe to my channel, and to receive the notification of my new videos, please press the bell icon. Thank you. Thanks for watching.